Dear third prep, today we will introduce the second lesson in Unit 4, which is position of a point and a straight line with respect to circle. It's Ms. Da'ai Giza with you today to introduce this lesson. Number 1, I want the position of a point with respect to a given circle. If I have a circle, the point here, it could be inside the circle or outside the circle or on the circle. You know the difference between the circle and the surface of the circle. The circle, the line outside, the line which is drawn the circle. This line is the circle. The surface of the circle, it's all the area inside this line. So this line is the circle. If I have a point A and the distance from the center to the point is greater than the radius length, so this point is outside the circle. And if I have the point A on the circle or on the line of the circle, this is called the circle. So you will find that the length of the distance from the center to this point is equal to R. Number 3, if A is inside the circle M, so I will find the distance from M to this point is smaller than R. So the position of the point defined by the radius length, the distance from the center to the point and the radius length. If the distance is greater than R, so this point is outside the circle. If the distance is equal to R, it's on the circle. If the distance is smaller than R, it's inside the circle. For example, I have circle M with radius length 5 centimeters, and the A is a point in its plane. The question is like this form, with no figure, with no circle, and I have only the length of the radius of the circle. If I have the distance MA equal to 5, so equal to 5, which is equal to R, so this point is on the circle. As we said before, if MA equal to R, so this point is on the circle. Number 2, MA equals 3, and the same, and I am in the same circle M, which is the radius 5. So 3 here is smaller than R, smaller than 5, so I can say that A is lie inside the circle. Number 3, MA is equal to 6.5 centimeters. 6.5 is a length greater than 5, which is the radius length. So this point is outside the circle. So we can define the position of the circle, of the point, according to circle, from the radius length and the distance from the center to this point. The last one is MA equals 0, not greater, not smaller, not equal to R. If MA equals 0 or the distance from the center to the point equals 0, so this point is inside the circle and this point is on the center of the circle, because there is no distance from the point to the center, so this point is the center of the circle. Second, the position of a straight line according to circle. Again, to define or to determine the distance, the position of a straight line according to circle, I have to know the perpendicular distance from the center to this straight line, and it should be the perpendicular distance here. The perpendicular distance from M to A, if it's greater than R, I will find that the drawn straight line here is outside the circle. So I can say that this line is outside the circle. And I have two remarks. Here, I want to understand what is this means. L intersect the circle M equal phi. I want the intersection between the straight line and the circle, or the line of the circle. So the straight line here is far from the circle, so the intersection here is far with the circle and with the surface of the circle. Both of them, the line here doesn't touch or intersect any point of the circle. Number 2, if MA equal to R, the distance from the center, the perpendicular distance from the center to the line is equal to R. So this line here touches the circle. This line here is called tangent. The tangent of the circle is the line which touches the circle at one point. So I will write here in the L intersect the circle at the point A. It's one point. It only touches the circle. If MA is equal to R, so I have this line is called a tangent of the circle. And the point A is called the point of tangency. Number 3, the straight line here is intersected the circle at 2 points or cut the circle up and down. Here I say that L intersects M equal X and Y. This line intersected the circle, the line of the circle at the point X and the point Y. But this line intersected the surface of the circle at the line segment XY, this part, and this is called secant of the circle. This line is called secant. So I have 3 positions. This line could be outside the circle. If MA greater than R, this line is a tangent. If MA is equal to R, this line is a secant if MA is smaller than R. If you notice here, MA is smaller than R. The difference between the circle and the surface of the circle, it's like the ring. You have a ring empty from the middle. This ring is a circle. It's empty from the point. But if you have a coin, it's a solid from. It's this coin, written on the coin, it's written on the surface of the circle. This is the difference between them. I have circle, which is the only line outside, so the intersection here is only X and Y. And the coin or the surface of the circle, which is all this area, so the intersection here or the common between them would be the line segment XY. And XY is called the chord of intersection. We have an example here. Also here, it's like the point, the position defined by the radius length of the circle and the distance from M to the line, or the perpendicular distance from M to this straight line, as we said in the example. Let M be a circle with radius length 5. MA is the perpendicular distance to the straight line L. I want to define the position of this straight line. First, MA or AM is equal to 5. I compare this length with the length of the radius. This is 5 and radius is 5. I have 2 equal lengths, so it's a tangent. Here, AM is 5 square root 3. First, I will find the value of 5 root 3. It's 8.6605 and so on. It's 8. And the 8 here is greater than 5. Every time I will compare the length of the line with the length of the radius. So 8 is greater than 5, so my straight line is outside the circle. Here, if AM is 5 over 2 or 2.5, so this straight line or this distance is smaller than R, so this straight line is a secant. I have important facts here. As we said that my distance, or the distance that define the position, it should to be perpendicular. Vice versa here, if I have a tangent, the tangent of the circle is perpendicular to the radius drawn from the point of tangency. If I have tangent here, if he say that AL is a tangent, so MA it must be perpendicular to AL from the point of tangency. Another remark, the straight line which is perpendicular is vice versa, it will be a tangent. So this line is a tangent if these two remarks are the same. But the difference here, what is the given and what is the required. If here he said that AL is a tangent, so I will say that MA is perpendicular, and vice versa. If the given here is MA perpendicular to the line L, I can say that this line is a tangent. Example, there's an example like this. He say that BD and CD are two tangents of circle M. B and C are the points of tangency. The intersection, they both intersect at the point D. BA is a diameter of circle M and a measure of angle A equal 50. He wants the angle of BDC. As we said before, if CD is a tangent, so MC is perpendicular to CD. So this angle here is 90 degrees. And I have another given that BD is also a tangent. So also MB from the center to the point of tangency is perpendicular to the tangent and makes angle 90 degrees with each other. Now I have angle C equal 90, angle D equal 90, B equal 90, and the angle D, angle A is 50. And we said before that the triangle AMC is an isosceles triangle because MC equal MA. So angle MAC is also 50 degrees. I can find angle BMC, which is exterior angle to this triangle, equal the sum of the two far angles or the two non-adjacent angles equal 50 plus 50 equal 100. Now I can find the measure of angle BDC using the quadrilateral the quadrilateral BMCD. 360 minus 90 plus 90 plus 100 equal 80 degrees. And this is our lesson today. Thank you very much.